break, so we'll be starting our second section. It happens to be that two organizers are giving the talk in the same session, so I'll be chairing this session. So we have 3 talks in this session, and we first have SpecTec, A Single Source of Truth by Sukyoung. Please give her big hands.
Hi everyone. To repeat what I said in the beginning of the first session, I'm so happy to see you all here. And some of the students from KAIST in my school told me, like, when I saw this workshop program, it was like your interest. And yes, this is a present to myself, because I was happy to see all those language mechanization work with K and Radix and verifications in WASM and JavaScript, ECMAScript, all those things. There are people who develop programming languages. There are people who write language specifications. There are people who use them and maintain them, the language communities and all that. And this is the workshop to get everyone in the same room and listen to their experiences and listen to their troubles and how to solve them together. So that's why we are here today. I'm so excited. And this talk is about our recent work on SpecTec. And actually, this was supposed to be given by Andreas. Where is his name? Yeah, Andreas here. Andreas was supposed to give this talk, but he couldn't make it. So he shared his slides on Working Group 2.16 this April. So his title was A Mechanized Language Spec in the Real World. And as you can see, it's a big project. The KAIST team, who are all here, and Philippa and Conrad, they are going to give a talk this afternoon. So we are happy to share our experience. March 27th this year, Andreas wrote this article. SpecTec has been adopted. 2 weeks ago, the WASM community group voted to adopt SpecTec. For authoring future editions of the WASM spec, in this post, he described what SpecTec is, what it helps with, and why it takes WASM to a new level of rigor and assurance that is unprecedented when it comes to language standards, right? And actually, if you go to read the meeting note, you can see that on March 11th, the community group had a poll, adopt SpecTec as the toolchain for authoring the WASM spec, and 15 strong in favor, 17 in favor, and 1 neutral. Yay, it's adopted. So what is SpecTec anyway? Thank you. What is SpecTec anyway? Before talking about SpecTec, let me start with WebAssembly. WebAssembly, in short, WASM. It is a binary instruction format for a stack-based virtual machine designed as a portable compilation target for programming languages. It is very well known to be well designed with formal language specification. For a language construct like binary operator, the spec describes the syntax and semantics in 2 ways. One in this natural language, step-by-step algorithmic explanation. Another in gray with our beloved Greek letters, like formal rules. Some people prefer this. JavaScript developers and WASM developers, people in industry, they don't even look at this. They love this. And the single editor of the WASM specification, Andreas Rosberg, he only wants to read this. And he even translated this to English phrases. So we have different kinds of people, and we'd like to help everyone. And yeah, so WASM 1.0 was introduced in this PLDI 17 paper. It was tiny, as Matthew and the Xiaoheng showed. This operation semantics, dynamic semantics is 1 page, and static semantics is even less than 1 page. It's very tiny. And the real specification, you can see this. On the left, we have dynamic semantics. On the right, we have static semantics validation. As I said, for each instruction, it describes the semantics in 2 ways. Prose algorithmic explanation and formal LaTeX declarative style. 2 ways. both for the dynamic semantics and the static semantics. Am I moving too much? Sorry. Yeah. And in order for a new language proposal is standardized to the specification, the community group is really picky. They are asking for 4 artifacts. In order for a language proposal, a feature proposal to be standardized, they need to describe the semantics formally in LaTeX and also specify the semantics in prose using the restructured markdown and implement the semantics in a reference interpreter in OCaml, and finally provide a test suite that can test the implementation of the feature. So all 4 things should be provided to sell your feature to the community. They do not require that yet, but they'd like to have even mechanized definitions and mechanized proof in this standardization process. So when I first heard that, I was like, is it possible? Can you do that? And actually it happened. And the language is that's really rigorous. But the thing is, because of these many steps and too much work to do, it's not that easy to make the language grow faster. So, for example, let's look at this instruction select. This is one instruction in WASM. The spec has this prose description and formal semantics. And what the spec editor writes is this. Prose description is restructured markdown and formal rules in LaTeX. So after writing all that, you are going to get this beautiful spec. So WASM is large, and it has over 500 instructions in the latest, not yet released, but soon to be released WASM 3.0. And its type system is not trivial. It's growing fast, and actually it wants to grow faster if all those mechanisms help. So it has already over 20 extensions since 1.0, but still missing important features. It currently has 15 completed and more than 20 active proposals, and the community wants to standardize it as soon as possible. So, fully formalizing this big and fast evolving language incurs various challenges, right? You can imagine that. The prose is a handcrafted translation of formal rules. As I said, Andreas writes the semantics in formal rules, inference rules first, and then translate that into English phrases. It's labor intensive, right? Tedious, error prone, and for some reasons, it's written in that weird looking restructured text. So that requires some tooling hacks. You can imagine that. And code reviews are painful and unreliable. Can you check the differences between LaTeX? I don't want to take a look at them, right? So spec differences for a single proposal, it's huge and not really human readable. Another thing is they really love mechanization, and Conrad has beautiful mechanization with Isabel for 1.0. And we'd like to have that for 2.0 and 3.0, but that requires a lot of work. It's really difficult to keep up with this fast evolving language. So here's our present, right? Instead of all this long specification description, what we want the editor to do is to write only these 6 lines in SpecTec. Then from this 6-line description, our SpecTec toolchain can generate this. Yay, it's kind of magic, right? So what is SpecTec? Finally, it's a domain-specific language for defining the WASM semantics and authoring the specification. It is the single source of truth in the sense that if we write that 6 lines, then the other artifacts are going to be automatically generated. It translates, like math rendering and that natural language, and rock definitions and the others. It's easy to write, read, and much easier to see the differences. And it's easy to review with, it also has some meta-level error checking. It is not a theorem prover, just a preprocessor. So again, whenever we have this kind of talk, people ask about, how about K? How about radix? So I loved Matthew's second slide. He sets the context of radix, where it is good for, right? Here, our SpecTec is an in-house tool for WASM, period. Okay? This SpecTec is especially specialized for the WASM specification, to be clear. So we are intentionally specialized to our use case. All the specs meta notation that's built in, but hopefully no more than that. And the backends can make domain-specific assumptions. Our tooling has, WASM-specific assumptions, and later I will show you the overall picture, but every single point has its specific assumptions. Especially the interpreter backends, it has lots of assumptions. And why? Because that really simplifies our work. We don't need to be general enough, because this is for us. We built it for us. So we control the implementation. We didn't take the risk of depending on someone else's tool. That's good for other purposes. We love K, we love radix, and we use auth. But for this purpose, we are making this decision. But it's still a research. A long-term maintenance is still an open problem, and we are looking into that. We are trying to make that better. So this is the overall picture. SpecTec, it's the DSL. That's 6 lines, right? When you describe the semantics, as Xiaohong said, when you define a language, you do better have a semantics, right? Like old programming languages, they started with implementations, not the semantics. Then what does it evaluate to? What's the value of this expression? Then often we heard like, let's run it. It's not the semantics, that's the implementation. So here, what we are saying is we'd better define the semantics first in this SpecTec DSL. And it has many layers, like it has this, several layers. The first layer is still declarative, which is easily emit LaTeX formalization. And after several transformations, we translate this declarative description to algorithmic description. Why? Because declarative specifications are good for proving, mechanizing formalizations and things like that, but they may not be good for running or understanding the semantics in a machine-like way, how to run it in step-by-step execution. So that's why we translate this declarative style to algorithmic style. Then we can generate a meta-level interpreter. I'm not going to go into the details, and we can finally emit prose descriptions. If you remember, that was algorithmic. Number 1, do this. Number 2, do that. And this is new. This is under submission, so I'm so sad that I cannot tell you the detail, but we do have a fancy fuzzer, and we can generate cool WASM tests, and that also revealed various bugs in the implementations of WASM. So this is the prior version of the spec editing, and now one can write this. This is getting shorter, right? And another thing is that we can mix manually written part and automatically generated part. You may not be able to read it, but there are some places saying splice in the automatically generated text here, encompassed by other manually written text, meaning that we do not need to get rid of the WASM 2.0 spec and replace that with a new one. We can incrementally replace the parts with the automatically generated ones. And on the left, we have manually written WASM 2.0 spec. On the right, we have automatically generated WASM 3.0. And if you just look at that as a picture, they look similar, right? Yeah. So if you take a closer look, they're up different. But yeah, that's good because you don't need to write all that. So that's the deal that we are making with the community group and the developers. Okay, WASM features. WASM 1.0, again, announced in 2017. It has the core-based language that Comrade proved. And 2.0 in 2020. It has the vector type SIMD instructions and reference types, multiple return values. WASM 3.0 will be released this year. And it has exception handling, garbage collection, tail calls, 64-bit address space, multiple memories, and things like that. All these features are now handled by SpecTec. And we are describing the semantics in SpecTec for continuations and effect handlers. So it's going really well. The reason that I'm enumerating all this exception handling proposal, garbage collection proposal, they are all individual proposals. They have their own 4 kinds of artifacts, right? Prose description, formal rules, test suite, and implementation. Only testing garbage collection. Only testing exception handling. I'm gonna get back to this point in a minute. Okay, by using mechanized language specifications, we could find so many bugs in JavaScript and in WASM implementations. And bugs found in spec and proposals of the WASM, like type errors like missing record fields in formal rules, semantic errors like missing index errors and missing stack operands, things like that. Prose errors like unbound variables, you're gonna be amused by learning that editors often use names without defining them, right? We do that too. And lots of editorial errors. So previously, spec editors had to check them, but now the tool can do that. And in order to see whether our tool is really useful, we collected bugs fixed in WASM 2.0 and, for the last 2 years and re-injected them and see whether SpecTec can help finding them. And yes, it was really helpful. And the details are in our PLDA paper last year. And with WASM, this is the bit that I cannot tell you the details. We can talk about that offline. Yeah, we are available. So we have a test generator for WASM by using this SpecTec. And we had the experiments with 5 major WASM engines, V8, SpiderMonkey, JavaScript Core, WASM Time, and WASMer. We found bugs in everywhere, right? And another cool thing, we knew that, but we just experienced that those implementations implement different specifications, right? V8 and SpiderMonkey implement WASM 3.0, even though it's not yet released. JavaScript Core, it implements WASM 3.0 except multi-memory and memory 64. WASM Time implements WASM 3.0 except for exception handling. And WASMer implements only WASM 2.0. So in order to test these 5 engines, you need different specifications. You need a way to create test suite for each implementation. It's onerous if you do that manually, but we have this tool. So we only need to change the spec a bit, then the tests are gonna be generated, targeted for each different implementation. So, so it's cool, but still it has many open questions, right? I was an editor of the cool language called Fortress specification, right? It died because it was so adventurous, but the spec was so beautiful because I was the editor, right? And back then, we were not sure how much mathematical notation is good for scientists and engineers. Scientists prefer to have mathematical notation. Developers, no, I don't care, give me the prose description. Right? Like best trade-off between what you see is what you get versus some ambiguity and complexity in the front end. In order to support mathematical notation, parser is a disaster, right? Just 2 things get together. That could be multiplication, string concatenation, function call, you name it. Right? So there are this big question. Also, SpecTec does not support evaluation context yet. it, as I said, it has lots of assumptions. Whenever Andreas does something cool, new, then the interpreter breaks. And he's like, why? And we were like, oh, here's the assumption. Let's make it more general and things like that. We are going that way. And we are interested, that's kind of a learning journey, I think. We are trying to get some balance trade-off between general enough language framework and language-specific framework and what not in between. What's the best option for other language like Rust or something else? So we are now interested in meta theory for SpecTec. We are also applying this technique to P4, yet another programming language, and we are realizing that SpecTec is really specialized to WASM. And we have now P4 SpecTec. Really? Do we want to have Rust SpecTec? Maybe not. Then what do we get from these experiences? That's gonna be my keynote talk tomorrow morning. Okay, with that, I think I'm done. Yeah, and thanks for listening. Yes.
Thank you for your talk. The argument for SpecTec for WASM and for not using things like K and Redux is that you want to specialize to WASM. So if you want to generalize to other languages, that's kind of circling back?
So again, it's a spoiler, but I can tell you that every language is different, and it's too big. Every language has different purpose and different client. Different users have different taste. For JavaScript, I think ECMAScript is the best. And Jihyuk and Michael are going to talk about ECMAScript in a minute, and they have very different purpose. WASM has different audience. And Rust, I'd like to learn more about Rust from Ralph this afternoon. And we have different preference, like because Ralph likes pseudocode as a specification, right? So yeah, in that sense, languages are different. I mean, programming languages are different. There's C and Rust for performance. There's Haskell and OCaml for higher level description. For this mechanized language specification, I believe that we have different applications and different platforms. It's not like making up new technique for each language. There are something common in it, and there are things different. So that's what we are trying to get. Thank you.
I guess actually just to add on to that as well, in some sense, the P4 project for SpecTec is doing exactly the right thing by forking SpecTec and making its own specialized SpecTec variant, right? We're not trying to change SpecTec so that it supports both P4 and WebAssembly at once, which I agree would put us in a difficult position with respect to this narrative.
Yeah. Philippa, get that microphone.
But at some point, we have to understand the commonalities, right? So the yeah. So that's where this discussion's going.
Yep.
Yeah.
You can say, yeah.
Very cool work. So last I knew, SpecTec was still kind of encoding assumptions for handling of numerics, especially like floating point numerics. So that's kind of from WASM 1.0, but like the actual details of the numerics. Is that still the case, or is there a plan for handling numerics inside SpecTec itself moving forward?
So yeah, correct.
My postdoc's done it.
Okay, cool. We should talk. Thanks.
The answer is
Some floats still to do, but a lot is done.
yeah.
we should
The
talk.
answer is
Thanks.
Comrade's postdoc is working on that. Okay, the last question.
Lovely talk. Your enthusiasm is very infectious. Thank you. So, for a follow up on all the previous questions, how specific is SpecTec to WASM? As I understand it, as someone who's not really in WASM, WASM is a stack-based language.
Mm-hmm.
So, is there anything in SpecTec that binds it only to languages that are stack-based?
Yeah, thanks for the great question. So this is the overall architecture, and it starts from this single source, and WASM again wants to have both declarative description and algorithmic description. K is more like rewriting system. So they have different tastes. And here, I think that we have WASM-specific assumptions in every edge. The picture may remain similar for different programming languages. P4 may have different interest because it's more like low-level data network kind of thingy, right? And higher-level languages like JavaScript, so you know what? It's really high-level function language. And its language specification is written in high-level function language with continuations as first-class values. They are different. So the main thing is not JavaScript programs or WASM programs. The main thing is JavaScript language specification and WASM specification, how that is written. And with JavaScript, we didn't even dare to change the spec, but WASM, because we are all one team, we are even changing the WASM specification to be more equipped to this model. So I think that's the difference. Okay, thank you. Thanks a lot.